So this is the solutions for worksheet 3 from chapter 9, numbers 6, 7, and 9. So when I look at solving a equation with rational expressions in it, the first thing I'd want to do is to factor all of my denominators. So x squared plus x minus 6, I see that that's going to factor to x plus 3 times x minus 2. And so what I'm going to do now is I'm going to determine what the least common multiple of the denominators are. So if I look at the denominators, I have the x plus 3 times x minus 2. I have a 1, because really that's 2 over 1. And I have an x minus 2. So my least common multiple of the denominators, I see two distinct prime factors. I see x plus 3's, and I see x minus 2's. The biggest power on my x plus 3's is to the first, and my biggest power on my x minus 2's is also to the first. So my least common multiple is just going to be x plus 3 times x minus 2. So I'm going to multiply everything in the equation by x plus 3 times x minus 2. So I'm going to have x plus 3 times x minus 2 times 5 over x plus 3 times x minus 2 equals x plus 3 times x minus 2 over 1 times 2 over 1 plus x plus 3 times x minus 2 over 1 times x plus minus 3 over x minus 2. So now I'm going to multiply these two fractions together to just kind of simplify things. So I notice that x plus 3's and x minus 2's can cancel, and I'm left with just 5 on that side. Next, I'm going to multiply these two fractions together. I notice that both the denominators are 1, so I don't really need to write the denominators anymore. And then I'm going to look at multiplying these two fractions together. Here I notice the x minus 2's can cancel. So I'm left with x plus 3 times x minus 3. Now I'm going to multiply these polynomials out. So x squared plus 3 times x minus 2. We already know what that foils out to because we factored it earlier. Then we multiply out x squared, or x plus 3 times x minus 3, and we get x squared minus 9. And now we'll distribute this through. So I have 2x squared plus 2x minus 12 plus x squared minus 9, and I'm left with a quadratic equation. So in order to solve this quadratic equation, I need to get everything onto one side and combine my like terms. So I have an 2x squared plus x squared is 3x squared. The only x term I have are the two x's. Negative 12 and negative 9 is negative 21, and then we'll subtract that 5 over, so that's going to be negative 26. And now, I might be able to factor that, I don't know by looking at it, but if I am going to be able to factor that, it's going to be a long factoring because the leading coefficient isn't 1. I'm going to have to do the factor by grouping stuff. If it's factorable at all, which I'm not sure just by looking at it, rather than go through all that for something that might not even factor, I'm just going to use the quadratic formula instead. So if I apply the quadratic formula, let's see, that's 316, I think, or 6. And now this is probably what you got, and you were confused as to how I got to my answer. Well, the way I got to my answer is I was able to reduce that radical, 316, So I noticed that 316 is the same thing as 4 times 79. So the square root of 316 is the same thing as the square root of 4 times the square root of 79. And the square root of 4 is just 2. So that. And now if you notice that each of these is divisible by 2, so I can just reduce this to be -1 plus or minus the square root of 79 over 3. Now if we move on to 7, this one's even a little easier, I think, because if I look at the denominators, there's really nothing to factor. I just have to determine what the least common multiple of the denominators are. So when I look at my 3 denominators, I see 2 distinct prime factors. I see x plus 6's, and I see x's. So I'm going to multiply both sides of this equation by x times x plus 6. So that's going to give me this. And now, just like we did last time, I'm going to multiply this first set of fractions together. I notice the x plus 6's are going to cancel. That leaves me x times x plus 1. Then I'll multiply these 2 fractions together. There I notice the x's are going to cancel. And that's going to leave me with x plus 6. And I'm going to multiply these 2 fractions together. There I notice that the x plus 6's are going to cancel. And that's going to leave me with x times 2x plus 1. So now I'm just going to distribute these out. And what I'm left with is a quadratic equation, so I'm going to move everything onto the same side. So I'm going to move everything onto the right-hand side. So I'm going to subtract x squared from both sides. I'm going to subtract 1x from both sides, and then another x from both sides. And then I'm going to subtract 6 from both sides. What I'm left with is a quadratic equation. This quadratic equation I can factor. I notice that it factors right away. And when I set each of these pieces equal to 0 and solve, I get +3 and -6. I guess it's worth noting here that I should really be checking these. So if I go back to the previous one that I did before, there's really no need to check this, because the only thing that's going to give me a 0 denominator is -3 or +2. And I don't know what this is, but it's not that. Here, again, I'm going to just check to see if if 3 gives me a 0 denominator. Clearly it doesn't. And -2, does that give me a 0 denominator? Clearly it doesn't. So both of those are good. And my last problem is number 9. I know I labeled it as number 8. That's a typo on my part. I believe that still is number 9. Let me check real quick. I checked. It is number 9. So again, I'm going to start by looking at my denominators. And my least common multiple for those denominators, well, I see 2 distinct prime factors. I see x minus 3's and x minus 5's. And since everything is to the first power, I know I just have x minus 3 times x minus 5. And I'm going to multiply that to both sides of the equation. So x minus 3 times x minus 5 over 1 times x plus 3 over x minus 3 plus x minus 3 times x minus 5 over 1 times x over x minus 5 equals x minus 3 times x minus 5 over 1 times x plus 5 over x minus 5. So again, we'll multiply these fractions together, and in doing so a bunch of stuff is going to cancel, leaving me with no denominators. So I have, for my first fraction, x minus 5 times x plus 3, and then I have x minus 3 times x, and then I have x minus 3 times x plus 5. And now I'm just going to go ahead and multiply all these things out. And what I'm left with is a quadratic equation, so I'm going to move everything onto one side. So I'm going to move everything onto the right side. So I have x squared, that's a plus there, I didn't do a good job of writing that, and plus another x squared, and then I'm going to subtract an x squared from that side. So I'm left with just one of those. So I have a negative 2x, a negative 3x, so that's negative 5x, and I'm going to subtract one of those over, so that gives me a negative 7x. And then I'm going to add this 15 over, and 15 and negative 15 give me 0. So if I factor that, I can just take out a greatest common factor of x. And when I set each of these equal to 0, I get x equals 0. And then if I add 7 to both sides, I get x equals 7. But I do need to make sure I go back and check. So if I look at x equals 0, I go back to the very beginning. If I plug 0 in for x, I don't get a 0 denominator. And if I plug 7 in for x, again, don't get a 0 denominator. So both of those answers are correct. I hope that helps.